All right. Let's just take a look at these. It was 4.7, right? All right. Here we go. So we have this triangle. Be quiet, he's trying to cheat. I know, dude, serious. It happens. I know. We gotta give Sawyer a break. He was in making up a quiz. Poor kid's been doing math for like 4 hours today. That's horrible. All right. So here's the different thing about problem number 1 is we're not proving any triangles being congruent. We're not going to CPCTC or anything like that because why? I only have one triangle, right? So they tell us that AB and AC are the same. Okay? So that should be enough to say that triangle ABC is isosceles, right? And the reason why? 2 legs congruent. What do you think? Is that an okay reason? I guess I could say theorem 4.8 or 4.9 or whatever it was, but I have 2 legs congruent, and if I have 2 legs congruent of a triangle, that means it has to be isosceles. And then if I were to go with that, then I could easily state that angle ABC is congruent, ABC to ACB. Definition of isosceles. Okay? So now that tells me that this is congruent to this. Agreed? I could then state that angle 1 plus angle ABC is equal to 180, as well as angle 2 plus angle ACB equals 180. I could state that. Why? Yeah.
Well, for the purple one,
Purple.
could you also do the drawing with like the congruent?
Yeah, that would totally. Yeah, I like that too. That'd be good. So it was asked if I could do that. I saw this on a couple people. You're doing a drawing. You have this equal or means this. Love it. I'm there. Now, is every math teacher in the world there? I don't know, but I like pictures. I like movies better, but you know sometimes Johnny's over your back screwing around doing nothing.
Come on, Johnny. I'm helping him.
No, with his science.
Yeah.
We're doing math, man. Come on, Johnny.
I'm doing math right
Come
now.
on, Johnny.
I'm doing process.
Then Johnny, why is this reason? Why?
Uh,
Huh?
is-
Huh? Huh? Good. Linear. Pair. There you go. See, I knew Johnny knew the answer. All right. We good there? So technically that would mean that I could take these. Right? Right? Transitive. And being that these angles are congruent, that means these are the same thing. So if I subtract those from both sides, I just get this. That's basically subtraction. And I'd say that's solved. That's what we wanted. Okay? Yeah.
So on a test or a quiz, that transitive one that
Yeah.
you just drew, would you rather have us do angle 1 plus ABC equals angle 2 plus ABC to say, would that be transitive?
We could make that leap. We could do that. It's not necessary. And the reason is what we had found was a lot of cases in that it's happening over and over again. So we're proving the exact same 3 things over and over and over again. So we're just now starting to make a leap. Oh, shh, here comes somebody. Oh, keep quiet. Hide.
Oh my goodness.
No
way.
Okay. Cool? Cool. Thanks. Uh-oh. say, oh, okay. Lois.
No, not to Lois.
And Johnny!
Yeah.
Oh,
Johnny!
yeah.
I hate it when I don't
Get in
know those
trouble.
notes. Let's see. It's because no one likes his name.
Come to the D
Oh,
now.
teacher. Oh.
It's not bad.
I've literally done like 4 of those.
Yeah.
Any for me?
What?
What?
Oh. I got one. Yeah.
For me?
No.
Anyone get one for me?
I fear. Oh, never mind.
Oh, yeah, story time going back.
Oh my god. Why do they do this? Never
What does it
that
say?
again.
Is he in trouble?
What did I do?
No.
Oh.
Yo, let me see. Let me see. What does it say?
Alright, calm down, everybody.
Used to just be
No, I don't want to go to that.
Waiting for the fellas in back. Don't blame Sawyer. That's a good blame. Alright. So this one, by looking at it, technically there are 2 triangles that possibly we might have to prove congruent, but I don't know yet. Okay? So our givens, we have KRM is congruent to, let's get up there, angle PRO. So KRM, so this one is congruent to PRO. Is that right? And then, is there anything I can really conclude off of that? Not really. So that's one of our givens. And then our next given, we have KR is congruent to PR. So KR and PR and we are trying to get to RM and RL. Okay. This is also given. Could I state that triangle KRP is isosceles? Could I do the diagram thing? Could I do this? I have this, so that means this. What do you think? Guys and girls, that make sense? Okay. Are we trying to prove this and this? So hang on. So let's see. Let's go with the crayon. Going with the crayon. So crayons. Okay. Do I have enough to prove the gold crayon triangles are congruent? Yeah, why? Angle side angle is the beast. Alright, so we can say that angle RKM is congruent to RPO. And that was, you said, angle side angle? So how will I now state this? How will I say that that is congruent to this? No? Yeah, it's why is it CPCTC?
Congruent triangle.
There you go. So RM is indeed congruent to RO because of CPCTC. And why can I go ahead and use CPCTC on this?
Because we already have the triangle.
I've already proven 2 triangles are congruent. Cool.
Good job, Bill.
So, other ways I might see this problem going, is what if, let's just add to this proof. Do we have enough information to say that angle RMO is congruent to angle ROM.
Yes. Oh yeah.
Why?
All the
It's what? Not vertical angles. It's the isosceles thing, right? Because right now, you see the two pink legs that I highlighted? I know it looks pretty bad. So that means the triangle RMO is isosceles triangle. And from that, then I can go ahead and start saying other things about the congruence. So just keep an eye on, there's only so many ways we can draw triangles overlapping each other. And this one, being that we would know that that triangle is congruent, we could easily state that this and this are congruent. Once we've said that's isosceles, there's just different ways we could build off this problem. Yeah.
What's the exact definition of CPCTC?
Corresponding parts of congruent triangles are congruent.
Okay.
Gotcha? Lucas thinks he got it, but I don't know if he got it.
Oh.
He might got it. Fake flashcards. Alright. 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 Guys and girls, there's some goofing off taking place. I don't want to turn around and see it, so make sure when I turn back around, you behave. Alright. So, I just wrote all the givens down. I don't know if I should go in order. So, we know that SX, so right here, is congruent to TY. That's a given. Is that enough to prove anything? Nope. Then WX is congruent to YZ. Is that enough to say anything's congruent? We have a side and a side so far. We had a third side. We could prove triangles if we had an angle in between, or an angle in between, or if we knew we had a right angle, maybe. And then SW. Cool. So we can go ahead and state those triangles are congruent, right? But that looks kind of weird. Like, why do we need that? Well, let's just see. Let's just prove what we know. Triangle SXW is congruent to triangle TYZ because of side, side, side. I love it. Okay? What are we even trying to prove here? I don't even know.
You're trying to prove RW is congruent to
RW, ooh, okay. I think we could do that right now. Yeah, so I can go ahead and state that angle W is congruent to angle Z. What do you think? Why?
The
CPCTC?
yeah.
Sure had. I wouldn't tease you. Do you need to go talk to somebody? Do you need a hug? Okay. Then we'll give him a hug.
Oh. Ouch. Harsh.
All right. Do I have enough to say that the big triangle is isosceles?
Yeah.
Yep. So triangle WRZ is isosceles. And we could do our thing saying, hey, we got this, then we know this. Right? Enough with the bottles.
What?
So is that good enough?
Yeah.
Well,
And then if then it, yeah, you're right, go ahead.
you're trying to prove that RW is congruent to Z or RZ.
I mean, that whole triangle is isosceles now, right? So then, of course, RW and RZ have to be congruent.
The reason would be
Definition of isosceles, exactly. RW is indeed congruent to RZ. Definition of isosceles.
Wait, so is number 6 of isosceles too?
Number 6 is, well, technically yes, but the diagram also makes sense. Remember the diagram we had yesterday?
Yeah.
Huh. These are so much easier than I thought.
Yeah.
What do you know? You're goofing off all through. You have no idea what
Oh.
Dang.
Oh, yesterday.
I didn't understand.
Oh my goodness.
I thought the guys' back were bad. I mean, you're up there playing with
Oh
math.
my goodness.
Cutting
Oh my
people there.
goodness.
You guys are off the hook.
Sick burn.
Hey,
That wasn't me.
Go on the shoulder. That was
Oh.
My God, so you're complaining like an old lady.
That
Like, oh, I have a cramp in my shoulder. Oh, you know, I got kicked yesterday. I fell downstairs last week.
wasn't me.
So he's like, what the heck are you talking about? Y'all, I know y'all pay attention to this group back here, because how can you not? Every time I turn around, it's like they are different seats. Someone's doing a headstand. Someone's like, oh, take a look at this. Hey, everyone's looking at a water bottle. Look at this.
Yeah, that's Sawyer. John.
Not that it's a bad thing, because you know what? If I was in this class, if I was like, not the teacher and I was a student, like if I was 16 years old again, I'd probably be sitting right back there too.
This is the cool part.
I got a really big astronaut.
John.
Don's out of control. See, I try to play nice, and then Don just takes it to the NC-17 situation. It's recorded. Now I got to edit out bad words. Don, bad kid. All right. No dying. I think number 4 should be okay.
Ooh.
I think number 4 should be okay. Yes? It's definitely a shared side. You have that GH that's goofing things up, so you have a reflexive property that's got to be in there. And then you can say FG plus GH is equal to GH plus HJ. Subtract GH, and then you can say show FG is HJ or corresponding parts. Yeah.
Wait,
Waiting.
so can we say that FG equals HJ?
Yep.
Just because of
Congruent parts. Congruent parts. That's a made-up excuse that we designed as this class.
so we don't have to go through it.
And then FK, JK, we know that. Then angle F and angle J are congruent because of our picture. Then that's angle on a side. Oh! No. Yes. Yeah. Cool. We could then prove. Let me do it. All right. Don, would you sit down? Will you take your meds or something, man?
I don't know.
You're bouncing around back there.
Feeling.
You're wanting me to get off task and start goofing off too?
Okay, okay. Okay, I'm gonna take some deep breaths.
Okay. Go get a splash of water. Go use some toilet water on your cheeks or something. I don't care.
Jesus Christ, dude.
Bye, Ben. Ben.
All right. Let's see if we can build off just the first given. All right. FH. So this and this are the same. So I think it's important that we do label that GH is congruent to itself just off of this. And this is reflexive because it's shared, right? But then we can easily just jump to FG is congruent to HJ. And that's just our made-up thing of congruent parts, right? I mean, that's not the real reason, but it's the reason I think we all come together as a class. The reason I can say that is because, you know, FG plus GH equals GH plus HJ. Subtract GH from both sides. And then we find that FG and HJ are the same. So now I know this and this are congruent. Good. Is there anything more that I could conclude off of that? No, it's not gonna, nothing. So let's go to the next one. Number 4. We're gonna go to FK. It's congruent to JK. That's given. Okay, let's see what I can do. This FK. Down's back. Good. So here and here are congruent. So if I could say those are congruent, what triangle can I say is isosceles first? FJK. There you go.
Freaking just kidding.
And then we can use our diagram. That yields to. Wait. Yes. I mean, that's basically what's going on. It's definition of isosceles. So then that's going to be the same type of thing that I can say is angle F is congruent to angle J. And I'd go definition of isosceles here. Yeah, buddy. All right. What are we trying to prove?
Triangle FKH is congruent to triangle JK.
That it? Really? FK what?
FKH is congruent
F?
to triangle.
Oh shoot. Okay.
Yeah.
So they want that. Do I have enough to prove the two small triangles are congruent?
Wait.
Yes.
Side angle side, okay. FGK is congruent to JHK. And that's side angle side, but that's not what we're trying to prove, is it? But that's going to allow me to say GK, number 8, I can say that GK is congruent to HK. That's our CPCTC. So now I know this is congruent to this.
Wait, but all you have to.
So here's the goofy part about this right now. Let's see if we can make this work. Creative pen vanishes. All right, so we're trying to get to this. That triangle here is congruent to this triangle here. Okay, so I know a side and an angle. Well, we know angle side doesn't work, right? So I can't prove those triangles are congruent by angle side. It's not going to work. But what can I say about the inside triangle, the pink, yellow, red triangle? No,
It's an isosceles triangle.
it's an isosceles triangle. We know that those, so that means those base angles have to be the same. So, triangle GHK, is that it?
Yeah.
It's isosceles. And this reason is we know the sides go to that, right?
Yeah. Angles right there.
And then, do I have enough? So this angle here is congruent to this angle here. So hang on, let's look. I have the yellow one here. I have a side, an angle, and an angle. Right? Side, angle, angle. Let me do this in a different color. This angle is congruent to this angle. So this triangle here, I have this side, this angle. I can't do the side, or I could go this whole side because I was given I have angle or side angle angle, which is angle angle side, right? Or I have side or angle side angle. I have either. They both work. So we've proven it. We can, let's just put it right here. We can say that our last thing, triangle FHK is indeed congruent, FHK, to JGK. And I have either angle, angle, side, which works. I have angle, angle, side. Or I have side, angle, side, angle. Cool. They both work. Yeah. Oy, yay, 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 yay. Talk to me.
Would side angle side work?
Yeah. Side angle side works too. Holy cow, any of those three. Cool. All right, I think you have enough of this. I think we're good. Pass it on in. Please. And, uh-oh. Yeah. I bet you we could have. I had forgotten about the long side. I'll be back. I am still recording.
What?
He's recording.
Follow me on Snapchat at JustJindo.
Getting so many new followers from Mr. Show subs. Darn. It's some screen time. Don, it fell. No.
Cal.
Then leave it.
No,
He's
Don.
dying. It's too late.
Don, no, we can do something. Don.
Yo, chill. Take it easy. Oh, that's actually pretty good.
I know, it was bad. Sorry. Rude. All right. Oh, did you guys pile them all up on my desk? Thank you.
There was a lot of screaming.
I understand. You guys were all recorded. All right. Too many for your row. Too many for your row. So it means hand them out appropriately, please. Oh, thank you. It's getting handed out. Ben, there's too many for your row, so pass it over to Sammy. Sammy, pass it forward, please. All right. Pass over to this row. All right. Today, proving triangles are congruent by first proving other triangles are congruent. Kind of sounds like a little bit what we're doing. 1, 2, 3, 4. 1, 2, 3, and 4. All right. Did everyone get one? Sorry, didn't get one.
There's an extra one.
There's an extra. White blood cell overdevelopment, is that what you got? That's what eczema is. That's psoriasis, actually. Eczema is just itchy skin. Develop and understand how to use CPCTC to find congruent parts and then use those parts to prove other triangles congruent. Okay, doesn't seem too tough yet. Remember how we added to our isosceles triangle to prove the base angles were congruent. Okay, I do remember that. Adding such lines can be helpful or even necessary, and some proofs such lines are called, I don't know, such lines are called something. you should make these lines dashed or dotted so the reader of the proof knows that these lines were added. Okay, so we're going to start dotting lines now.
Oh, auxiliary lines.
What is it called?
Auxiliary lines. I had a question about this.
Yeah, where'd you find
I was
that?
gonna ask
How'd you spell it?
AUZ
A-U.
X.
AUZI.
BC.
Lines.
That's the auxiliary board.
Shoot. Where was this at? Where's it?
Wait, when
Where'd you
write
find that? Where'd you see it?
When you write an auxiliary line as a given,
Where?
like a statement, what do you write for the reason?
There's a what?
Are you okay? Are you okay? No, there's no
Where'd you find the auxiliary though?
It's at the back.
Oh, thanks.
Auxiliary line. I see it. AUXILLIARY.
So it's A-U-X-I-L-I-A-R-Y. All right, sweet. So we're adding lines to it, so there's certain things that we can add to make things. No, you should make these lines dashed, dotted, so the readers, okay. Readers being the teacher. Hey, is OC a radius? Is OC a radius?
Yeah.
No. Okay. So we know things. We have circle O, and then, so we have circle O, and then we have OC is perpendicular to AB. Those are our givens, right? Okay, so is AC or CB a radius? No. So we don't have a radius that we know, but we do know this, and we do know this.
Whoa.
You see those dotted lines? All right, so we have those dotted lines. So I can go ahead and state that OA is congruent to OB. Why?
Definition of
Radius. So I just drew it in, and now I can start using it as my own. So radius, right? Or radii?
And then could you say OC is congruent to OC?
I like that. So OC is congruent to OC. And we got, what's the reason? That's reflexive, right?
Yeah.
All right, so we know that. So we know this is congruent to this, and we know this is congruent. And then we have OC is perpendicular, so I know I have that and that, right? So is that going to allow me to say that angle ACO? Angle ACO and angle ACO and BCO are equal to 90 degrees? Why is that?
Definition perpendicular.
Yeah, perpendicular. Right?
Number 3 reason.
Huh?
What's number 3 the reason?
Reflexive. OC. Okay, so do I need to say now those two 90-degree angles are equal, or is it just known?
You have to say
It's just known. What do I have? What are two things that we know about this? Do I know a hypotenuse?
Yeah.
And do I know a leg?
Yeah.
Yes. So can AC? So can I prove the two triangles are congruent? For what reason? So triangle ACO is congruent to triangle BCO because of what? HL, hypotenuse leg. Good. And then we can say what?
You can say
You can prove AC and BC are congruent. There you go. Cone extend. So AC, CB. BC. And that's CPCTC. Done. Yeah.
Since OC is perpendicular to AB, couldn't you have stated that AC is congruent to BC right after the givens?
No. I mean, there's other things that we could have done off of that, but I think you have to prove the two triangles. You can't make that jump. Perpendicular doesn't mean it's a perpendicular bisector. All right. What's different about this type of problem? We had to draw in the rest of a shape, right? Made it dashed, and go with it. What do you do to prove two angles or two sides are congruent? Sometimes to prove two triangles are congruent, you must first prove two different triangles are congruent, then use CPCTC, and then you finally prove that the requested triangle is congruent. Oh my gosh, that's good grammar. Proofs using this type of strategy may be referred to as detour proofs.
Hate this.
Huh. So sometimes you have to chase a dog around a tree in order to prove that there's actually a tree there, right?
Maybe.
What the heck does that even mean? Just go with it. All right. So let's do in crayon. Crayon. We want ABE. We want that and this to be proven congruent, right? Okay, using the old crayons. All right, so what do we know? We know AB is congruent to AD. That's given. So AB, AD, cool. Is there anything I can, ooh, hey, take a look.
Wait, because then you could do like the.
That's a lot of reflection.
It is that whole big red triangle is isosceles. Agreed? So just from that, we can go ahead and state that angle ABE is congruent to angle. Wait. Before I prove that, I want to put here. I want to say that triangle ABD is isosceles. And the reason is we already have this. We're trying to go to this. Or then that. And then that's going to lead me to say that ABE and angle ADE are congruent. Definition of isosceles. So now I know this and this. So I have a side and an angle. I guess I could go ahead and make the obvious statement that AE is reflexive to itself, right? Okay, and that gives me angle side to side, and we know that doesn't work. Shoot.
The AED, the angle AED
AE.
is congruent to AEB. Because
Why?
it's like the opposite sides or whatever.
So these two angles here?
Yeah.
I can't say that yet. I like what you're thinking, but I can't get there yet. All right, so that's what I just got off our first givens. Let's go to our second given, see if we can do something with that. Step 4, BC is congruent to CD. That's given. Okay, so BC, so there, and that. Huh. I can't say that yet because I don't know if there are 90-degree angles.
Oh.
I don't know if there's perpendicular. So, but my second given, I state this. So now I could state that this triangle is isosceles, right? So I'm just going to put that here so we don't have to go off the screen. So triangle BCD is isosceles because we know we're going from sides to angles. And then I could state that this angle and this angle are congruent. So angle EBC is congruent to angle EDC, EDC. Definition isosceles. Oh shoot, ABE, ABE, ABE Maybe.
Did you say CE is congruent to CE?
I can definitely say CE and CE, and that gives me angle side side again.
No, wait. Could you see CA?
Done. No.
Wait.
Oh, I'm almost there. Shoot. Where are we at?
We're in the same class we've been in the whole time, you moron. Okay.
Where should we go with this? Yeah. Angle ABE and angle what? EBC? They're not 180. But I think, I like where you're going with it, but I think what you could go with on that is, this is going to be a really long proof. So I would definitely say that angle ABC is congruent to angle ADC because you have congruent, smaller angles make angle like that. And then you can go side angle side to this triangle. You know, we're going to finish this tomorrow.
Homework?
See,
Agreed.
get a start on the worksheet.
Yeah, take a look at what the worksheet would have been. Sound good? But we're not going to get done with this today. I'm sorry. I wish I did.
Oh, man.
Bad,
It's okay, take your time.
bad teacher.
Take your
I'm telling
time.
you. Yeah.
Take your time.